Alright everybody, what's up? We're going to be talking about properties of circles and tangents. What? So pumped! Let's go ahead and do this. Alright, now here we're looking at a circle. Love me some circles. Now, we have to name this circle. The way we do it is we need a center of the circle. So, we put a dot in the center, and we actually name circles by their center. Okay, so we're going to call this circle C. Okay, because circles start with a C, so it makes sense. Okay, parts of a circle. First we have a radius. Alright, radius is from the center to the edge of a circle. I hope that you're familiar with that. But that's the idea. Center to the edge, that's a radius. Okay? Now a diameter goes from one edge of the circle to the other, but has to go through the center of the circle. Okay? We can also think that a diameter is twice the length of the radius, because it's really two radii together. Next we have a chord. Now a chord is one part of the circle to the next, but does not go through the center. So a chord never goes through the center of the circle. And next, something I left out is something that shoots through the circle, okay, and cuts along, and it is called a secant. It intersects the circle in 2 points, okay? Intersects the circle in 2 points. It's called the secant. I'm going to work on spelling that right. Nice. So let's move on, now that we've got our beautiful secant. Right? We're going to talk about something called coplanar circles. Now, it doesn't mean coplanar. Coplanar means that they lie in the same plane. Here we have a picture of concentric circles that are inside of each other. All right? They don't intersect. But let's see what they do look like when they do intersect. Okay? So, we're going to pull the smaller circle out, and if we just lay them next to each other, they have 1 point of intersection. Okay? But if we pull it in a little bit, they have 2 points of intersection. These are points of intersection for a circle, of coplanar circles. Let's move on. Okay, now we have something called common tangents. So what is a tangent? Well, a tangent is a line that is perpendicular to the radius of a circle. So it only meets the circle at 1 point. Okay, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint of the circle. Okay, so here we have it touching the circle, and it is perpendicular to the radius. That tells me it truly is tangent. Okay, so at point P, we see that it is tangent to line M. Beautiful! I'm ready to move on. I hope you are too. Okay, so now that we've talked about tangent, how many common tangents can circles have? Well, 2 separate circles can have multiple lines being tangent to them. Unfortunately here, I don't really have lines, I have rays, so please don't hold that against me. It's kind of like what was available to me in this program. Okay, so I'm just I'm listing all of the rays, kind of moving all around, and I wish they were lines, but they're rays. And so, yeah, just placing them around. Now if I have 2 separate circles, and that's what I'm doing, okay, is placing them all around, they're actually going to have 4 common tangents. Alright, so this is taking a little longer than I expected, but yeah, 4 common tangents, and that's beautiful. Alright, now what if the 2 circles have 1 point of intersection? Okay, well, we would still have the 2 common tangents on the outside, okay, which we're seeing just like the previous one. But in addition to these 2 common tangents on the exterior, we can still have 1 common tangent that runs through the center. Okay, so here we go. Boop. We're going to go ahead and move it down. Boop. And it's common tangent right between the 2. But if they are intersecting, that they have 2 points of intersection, hachi-machi, we're going to see that they are going to have only 2 common tangents. Okay, only 2 common tangents in this case. All right, I don't know why I took a full minute of this video to show you common tangents, but it's a good thing to know. All right. So in addition to this, we're going to be talking about lines tangent to a circle. Okay, and as you previously saw on this page that I'm about to show you once I put that in place, oh, that is beautiful. I feel good about life now. Here we go, next page. So, tangent to a circle. We've seen this, and we're talking about how it's going to be perpendicular, and it's going to be beautiful. Well, how can I tell if it's perpendicular? Well, I could actually use the Pythagorean theorem, like a boss, to go ahead and figure that out. So, if I'm going to take a little line, and I'm going to extend it, it's going to be beautiful. I could use the Pythagorean theorem to check this, okay? Which would be amazing. Okay, so let's say I put my right angle here, alright, because it's supposed to be perpendicular. Now this would not be A. Haha, I was just trolling you to see if you would think that was A, but it's hypotenuse is never A. We know that that was the hypotenuse because it was opposite the right angle. So here I have A, leg B, and we have hypotenuse C. Beautiful. Now that we've labeled that, let's go on to the next page. Here I have a triangle, okay, and I'm trying to see that if this line of 60 really is tangent. Now, for me to check that, I have to figure out what is a squared plus b squared equaling c squared. Well, I'd have 25 squared, which is 625. I'd have 60 squared, which would be 3,600. And don't look at that page. And then I would go ahead and solve for the last one, and I guess I don't do that on here, so happy love to all of these tangents, and that's how we can tell if a point is tangent. Thanks so much, and I hope you have a wonderful day.